Hey everyone, today we're going to be wrapping up transformations by putting it all together and then also adding one additional transformation, which is the stretching or compressing. So let's go ahead and dive in. First of all, we're going to do a little recap. So what I want you to do is identify what transformation is happening in each of these four problems. So the first one, this minus 3 here is telling us that we're going to shift the function down 3. Notice there's no parentheses, so think of it as sort of being on the outside. In the past videos, we said that if it's on the outside, we're going to move it up or down. So if it was a plus 3, we would have moved it up 3. The next one, notice this 2 is on the inside, which means we're going to move it left or right. It's on the inside of parentheses. Could also be on the inside of like a radical or something like that. But notice one thing, whereas the first one, it makes sense. Minus would be down. You would think positive would be up. Remember, when it's on the inside, it's the opposite of what you'd think. So plus 3, you'd probably think right 3 because that's the positive x direction. It's actually it's actually opposite. It's going to be left 3. So remember that it is the opposite. Okay, the next one, this negative x squared. Again, notice that this is, we're going to say on the outside because there is no parentheses, no square root or anything. So when it's on the outside, reflect over the x-axis. And then the last one, notice the negative is on the inside, which means we're going to reflect over the y-axis. All right, so hopefully you did well with that quick recap there. And we're going to add one additional transformation, and then we're going to put all those together. So the last transformation we're going to talk about is called stretching or compressing. So if you can visualize taking this function, whatever it be, and stretching it out, or you can sort of smash it down. This is going to be the case if we multiply something times our function. So our first example would be, let's say we have this function f of x is 3x squared. Okay. And the number in front here is what we're going to refer to as the a. So this is a times f of x. If that number, the absolute value of the number, is greater than 1, which is the case in this example, we're going to stretch the function, meaning making it longer. And if that is a number between 0 and 1, the absolute value of it, so let's say like 1/2 or 0.3, something like that, then we're going to say we're going to compress it. So that would be the example, f of x equals, say, 1/2 x squared. This notation is a little bit confusing in that math language there. Basically, all we're saying, if it's between 0 and 1, that's just saying if it's a fraction or decimal. So you might want to think of it in that way. If it's a fraction or decimal, then it's going to be compressed, sort of smushed down. And if it's greater than 1, like 2 or 3 or 4 or 5, something like that, then we're going to stretch it. So if it's fraction or decimal, it gets smaller, shrinks. How we're practically going to do this is we're going to be multiplying the y coordinates by whatever that a is. So we'll look at an example here. Let's take that first example of f of x equals 3x squared. So the parent function of this graph is just x squared, right? So if I were to just plot that real quick, my function would have points at 0, 0, 1, 1, negative 1, 1. So 2 would be at 4, right? Negative 2 would be at 4 as well. So this is my parent function, x squared. And we know these would have points at 0, 0. Let's just look at this one, 1, 1, and 2, 4. All right, because 0 squared is 0, 1 squared is 1. We've done this before. Now, when I actually apply the transformation, how I know where to put these, I know my function's going to, sort of be skinnier and stretched out. I know it's going to do that. But how exactly where do I put these points? Well, I'm going to multiply the y coordinates by a. So the first one, 0, 0, well, 0 times 0 is just going to stay the same, so going to stay there. However, in the second coordinate, all I'm going to do is change the y coordinate. I'm going to multiply the y there, which is 1, by my a. My a is 3. So this, instead of being a 1, 1, is going to be 1, 3. So it's going to go up there. And my next one, this is the a. I'm going to multiply that by 3. So 3 times 4 would be 12. So 2 would actually go all the way up to 12, somewhere way up here. 2, 12. And this would be 1, 3. And this one would still be 0, 0. So this would get stretched out like this. Also in the negatives, this is negative 1, 1. So when I multiply that by 3, well, that's going to put me at negative 1, 3. Same thing up here. So it's going to be stretching this function out. Keeps the same shape as the parent function, but it just gets stretched out. That's what the 3 does. And the opposite would be the case if I were to have something like if I had something like a half. So like f of x equals 1/2 x squared. My parent function would, again, still be the same. So I've still got my 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So there's my parent function. Now this time, write my points here, 0, 0, 1, 1, 2, 4. All my y's get multiplied by 1/2. So 0, 0 is still going to stay there. But this 1, 1 will now be 1, 1/2, because a half times 1 is a half. And this one, the 4 gets multiplied by a half, which would be 2. So 2 is going to be at 2. And same in the negative direction, the same thing is going to happen. So what happens is that function gets wider. So it's compressed, it gets wider. So another way that you can think of this, if we're stretching or compressing, just in more common terms, you could think of this as getting skinnier versus wider. And we'll apply this some more when we look at the assignment here. But that's the basic shape. If we've got a number that's like 3 or 4 or 5, we're going to stretch it so it's going to get skinnier. If it's a number like a half or a third or 0.2, we're going to compress it so it gets smushed down and becomes wider. All right, now putting this all together, we had these other transformations that we talked about on the previous one, right? Shifting it up, down, left, right, reflecting over these axes. So the question is, well, what if I have a function that has all of these in one function? How do I know what order to apply these transformations? And that's what we're going to talk about on our last slide here. So this is going to be important because when we put all this together on our assignment, we need to know, well, do I reflect it first? Do I stretch it first? Do I shift it up first? Do I shift it down, left, right? What do I need to do? So this is our general formula here. A times x minus h plus k, meaning A would be our stretch or compress, our h would be our shift left and right, k would be shifting up and down. For the reflections, we could theoretically have a negative in front of the a or a negative in front of the x. But given this general form here, let's say, for example, I have an equation like negative 3 times x plus 2 squared minus 5. And I'm going to graph this using transformations, but how do I know where to start? I know I can start with the parent function, which is y equals x squared. But what do I do first? Do I move it left first? Do I move it right first? I'm up first, down first? Do I stretch it? And the other question is, well, does it matter? The answer is yes, it does matter. There is an order that we need to do these. And I want you to try to think of this sort of from the inside out. So think of this as inside out. That's the order that we're going to apply these. So if I were to look at this function, this negative 3 times x plus 2 squared minus 5, the very inside, what I'm going to do first is actually that plus 2. And that is my horizontal shift. So do I move it left or right first? So in that case, I would move it left 2 first. So working from the inside out. The next thing I'm going to do is my reflections, because there could be a negative here outside. There could also be a negative here. So we're going to do the reflections next. The next thing is going to be my stretch or compress. And then lastly, I'm going to do my vertical shift because it's way on the outside. So the reason reflections come before stretch or compress is because that reflection could be right there or it could be on the outside. Either way, it doesn't really matter because with multiplication, it doesn't matter the order that you do the multiplication. So we're always going to do our shifts first, horizontal shifts, and then we're going to do our reflections, and then our stretches or compressions, and then lastly is going to be our vertical shifts. So important that you know that order when you are applying all these together. All right, so let's take this and apply it. We're going to be looking at an assignment on Delta Math for this. We've done a few that are similar to this, where it gives you a parent function, and then you have to transform this. So just like as in the past, when we click this, the green dot moves up, down, left, and right. And then these blue dots, you drag them to sort of manipulate the function for reflections. We're also going to use this to stretch it and compress it as well. You can see how you can make it skinnier or wider. Okay, so given all that, let's take our first function here, and let's see if we can figure out the transformations. So we're given our parent function. Let's just write out the transformations that we're going to do first of all. Well, if we go in the order that I just outlined, this one is going to be first, right? That -1. That tells us to go right 1. So I'm going to go ahead and just take my function, grab the green dot, and move it right 1. Okay, got that one settled. There's no stretches or compressions for this one, so we're good there. The next thing that we need to do is look at this minus sign. That tells us to reflect over the x. So we're going to grab a dot. It doesn't matter which one. I always generally just grab this one that's originally at 1, 1 and just go ahead and reflect it there. So reflecting over the x-axis, that's this axis here, which means we're going to reflect it down. So I'm just going to pull this one, go straight down. It was there at +1, right? +1, 1. It was there. So when I reflect it down over the x, that changes the y's. If you remember from our previous one, so that makes it 1, -1. It flips all the y's. So let's multiply y's by -1. That's essentially what we're doing. So let's go ahead and try this. There's no other transformation, so let's see if we did it right. Go ahead and submit our answer. And there we go. All right, let's go ahead and try a couple more of these. Okay, so this one we've got a stretch or compress. So we haven't seen one like this yet. Now there's actually no other transformations. There's no shift down, up, up, down, left, right, anything like that. No reflections. All we have is this 1/2. That tells us we're going to compress it, right? Because it's between 0 and 1. So we're going to compress. And as we said in the notes, when we compress this, we're going to multiply the y coordinates by that a. Multiply the y coordinates. So let's do that. All you need to do is pick one of them and multiply the y's. I'm going to go ahead and write these out. This one's 1, 1. This one is 4, 2. This one is 9, 3. Sometimes it is helpful to look at more than one. All you have to do is move one of these points on here, and it moves all of them, but it's good to look at all of the coordinates. So when we compress, we're multiplying the y coordinates by whatever that a is. So this one, the first one, 1, 1, it's going to change to 1, 1 times 1/2, which ultimately takes us to 1, 1/2. The second one, 4, 2, we'll multiply the y coordinate, so 4, 2 times 1/2. 2 times 1/2 is just 1, so this becomes 4, 1. The last one was 9, 3. So that becomes 9 comma 3 times a half. So that becomes 9 comma 3 halves. So what we need to do is move these points. Now, like I said, you only have to move one of them. This first one, if we try to move it to a half, it's a little hard to be 100% accurate. And if you're not 100% accurate, then it will tell you that you're wrong. So I think you can do it on this one. You can see it's at 1 half, but I would just double check these other ones. 4 comma 1, that looks good. And then 9 comma 3 halves, that looks good as well. So we should be good with that submission. Again, all I had to move was 1, but I could have just as well moved this 4 comma 1, put it there, and that worked as well. And notice how it compressed it, kind of, smushed it down. All right, let's go ahead and submit this and see how we did. Very good. All right, let's go ahead and try a couple more. This one, we did this on the last one, so we won't spend a lot of time on this one, but it is good to review here. This negative on the outside, that tells us to reflect over the x. So if we go ahead and do that, let's go ahead and put that there, reflecting over the x-axis. Try the next one. All right, this one has multiple transformations here. Let's go ahead and do this one. So let's think about the order we want to do these. We have two things going on. The parent function is just x cubed. We have this minus out in front, and then we also have a -5 on the outside. So think about your order. Think of it like sort of inside out. And remember, if there's something on the outside, a plus or minus on the outside, this is always going to be the last thing that you do. It's always the case. So the first thing we need to do then is apply that negative sign. Since the negative is not inside of any parentheses, that's going to be a reflect over the x. So we're going to go ahead and do that first. So just choose point. I always like to start with this one. If we reflect that over the x, it was at 1, 1. So we're going to reflect it down to 1, -1. So we got a good reflection there. Our next transformation that we need to apply is this -5. Since it's on the outside, that's going to tell us up or down, and that's going to tell us to move down 5. So then we want to grab the green one and shift this whole function down 5. It was at 0, 0, so we're going to move it down to 0, -5. And there we go. All right, let's go ahead and do one more like this, and then we'll try to do another stretch or compress as well. All right, let's think about the order on this one. We've got two things we need to do. We have a +2, and then we have a minus on the outside. So we want to do inside out, which means we're going to do that +2 first. That +2 tells us we're going to move left 2. Let's go ahead and take the function, the green one here, move it left 2. We then are going to reflect it over the x again. You can see that reflecting over the x-axis is a lot more common than reflecting over the y-axis. So then we're just going to take this one and reflect it down to here. And we should be good to go. All right, let's go ahead and try to find, I want to do one more. Here we go. This will be perfect. All right, this one, we've got two transformations again. We've got this -4 and we've got this ×2 here. So think about the order. That -4 is on the outside, so we're going to definitely do that last, which means we need to do that 2 first. So this is going to be a stretch by a factor of 2, which means we're going to be multiplying the y coordinates by 2. So let's go ahead and just write out a couple of these at least. This one here is 1, 1, and this one is 8, 2. So let's just take these two, 1, 1, and 8, 2, and we need to multiply the y's by 2. So this is going to become 1 comma 1 times 2. And you can probably do that in your head. That's fine. Just going to show you the work here. And this one becomes 8 comma 2 times 2. Just multiplying the y's. This first one becomes 1 comma 2. And the next one becomes 8 comma 4. So for our first transformation, we're just going to take one of our coordinates. Let's just take the first one. It's supposed to go to 1 comma 2. So we're going to shift that up to 1 comma 2. And then the other thing that I want to do is make sure this other coordinate here matches what we said it should be. So it was 8 comma 2. It should now be 8 comma 4. And if you look, that is the case. So we're good. We got that stretch done. We can't forget about our other transformation though out here, which is that minus 4. Since it's on the outside, that's going to tell us to move down 4. So just pick a point. It's easiest to just choose the one at the origin here where the green dot is. And that's at 0, 0. We're just going to move it down 4 spaces. 1, 2, 3, 4. And there we go. All right, and I think I will do one more to show you another stretch here. This one has 2 transformations. It's got a 4 and a minus 2. Think inside out on this one, which means we're going to apply that shift first, the minus 2. That tells us to go right 2. So let's go ahead and do that. Grab the green one, shift that right 2 spaces. And then the 4 there is going to be a stretch. We want to multiply the y's by 4. So let's identify a few of these new y coordinates. This one is currently at 3 comma 1. This one is at 4 comma 4. And we could also do this one actually. So that 2 comma 0. So let's do those 3 coordinates. 2 comma 0, 3 comma 1, and 4 comma 4. And each of these we're going to multiply the y's by 4. So this goes to 2 comma 4 times 0, which is actually still 0. The next one is 3 comma 1 times 4, which is 4. And the last one, 4 comma 4 times 4, which is 16. All right, so let's grab one of these. Go ahead and erase this. Grab one here. And let's do this one. The 3 comma 1 changes to 3 comma 4. So 3 and then up to 4. And there we stretched it. We made it a lot skinnier. We sort of stretched it out. I like to think of, if you ever seen one of those toys, back in the day I used to play with this thing called a Stretch Armstrong, where you could stretch this guy's arms and his whole body stretched out. It was really neat. If you have never seen it before, look that up. That's pretty cool. I don't know if they still make them, but I like to envision Stretch Armstrong in this. So look that up if you get a chance. All right, so we can double check here. We still got 2, 0, 3, 4, 4, 16. We can't see up there, but it seems like that will eventually fit. So let's go ahead and submit that one. And there we go. All right. Hopefully you guys are good to go with that. If you are still struggling with anything, just a couple reminders. You can always see an example on these. So you can always do, for me it says show solution, but for you it'll say show an example. So it shows you what to do. And then also remember there's that extra help video on all of these. You can just click that watch help video and reach out to me if you still need help. All right, see ya.